Hey guys, this is another video I made for the Math Learning Center that I'm just going to reuse for my 221 class. We are given three lines in the xy plane, and the region of interest is the region that is bounded by those three lines. We are also given a transformation going from the uv plane to the xy plane, and we want to determine what the corresponding region in the uv plane is. Given the transformation, each one of these boundary lines is going to be a boundary line of a region in the UV plane. So the idea is to see what each one of the boundary lines are going to be in the UV plane, and then the corresponding region is going to be the region that is inside of those boundary lines. We'll begin with the line y is equal to minus x plus 4, and we just want to write this in terms of u and v. And so we'll color code, and this will be the orange line. So this becomes 1/2 times u minus v, because y is equal to 1/2 u minus v, is equal to minus 1/2 u plus v plus 4. And if you rearrange this, this becomes u is equal to 4. The line y equals x plus 1 will be green, and again, writing this in terms of u and v, we get 1/2 times u minus v is equal to 1/2 times u plus v plus 1. Rearranging this, we get that v is equal to minus 1. Now we'll do the last boundary line, but first, to make things a little more convenient, we'll multiply both sides by 3. And so we end up with 3/2 times u minus v is equal to 1/2 u plus v minus 4. And again, rearranging this, we get that v is equal to 1/2 u plus 2. Next, we'll sketch these lines in the UV plane. The u-axis is the horizontal axis, the v-axis is the vertical axis. We'll start with the orange line. This is the vertical line, u is equal to 4. Next, we'll do the horizontal line, v is equal to minus 1. Next, we'll do the blue line. This intersects the horizontal green line when u is equal to minus 6. And we know that just because we're solving the equation minus 1 is equal to 1/2 u plus 2, and the solution to this is u is equal to minus 6. Now this is a very simple region. For comparison, let's look at what the region in the xy plane is. This is the Desmos graph of the region in the xy plane. This line is the line y is equal to x plus 1. This is the line y is equal to minus x plus 4. And then the last line is the line y is equal to minus 1/3 x minus 4/3. Now, if we think about this as a domain of integration, whether we do the y integral on the inside or the x integral on the inside, we'll have to split up the integral into two integrals. So if we do the y integral on the inside or the x integral on the inside, we'll have to split this integral up into two integrals because the boundary curves change. This is inconvenient, and it's just better to not have to do that. Now let's go back to the UV plane and see how the region in the UV plane is simpler to integrate over than this region. First, we see that the u values go from minus 6 to 4, and then if we integrate with the v integral on the inside, we're always going to go from the green line up to the blue line, so we can do everything in one integral. This is one of the main uses of u substitution in Calc 3. It's not necessarily because the integrand is difficult, it's because the region that we're integrating over is difficult. We'll see examples of this in a few videos.